Hi everyone, welcome to today's tutorial. So this is physics 101 and I'm going to be helping you to go through the tutorial sheet, and I'm making sure that each and every day at least I solve 4 questions from each tutorial sheet. Yeah, so mathematics I'll be solving at least 4, even in physics I'll be solving 4. Okay, so let's quickly begin. So if you've not yet subscribed to the channel, click on the button so that you do not remain, or you do not miss out the videos that I'm going to be posting. Yeah, so let's quickly begin. So to start with, these are vectors, and vectors according to physics are just quantities which have both magnitude and direction. Okay, so that when they talk about direction, they're simply talking about the angle. Don't get confused when they say direction. Direction is simply just the angle. So when they say find the displacement of a vector, it means that you need to find both the angle and the magnitude of a vector. So now the question says a displacement b of 100 meters from the origin at an angle of 37 degrees above the x-axis. So you can be drawing this. Physics, you don't just read questions, you have to be imagining and drawing them. At least you draw a free body diagram. Okay, so you're going to have something like this. This is our x or y plane, and then we've been told to say this displacement b of 100 meters from the origin, if this is our origin, from the origin at an angle of 37 degrees above the x-axis is, so they are telling us to say it's 37 degrees above the x-axis. So this is what I'm going to say. So this is my displacement b. So this is the angle, which is 37 degrees, and then apart from that, we've been told to say this has the magnitude of 100 meters. And then apart from that, the question says above the x-axis and is the result of 3 successive displacements. So we have 3 successive displacements, which are b1, and then b1 has been said to be along the negative x-axis. So b1 is in the negative x-axis, so just draw it a little bit on top of the x-axis like that. So b1 is along the negative x-axis, meaning the displacement, or rather meaning the angle of this b1 is 0 degrees. Okay, so what other, okay, we also have b2 of magnitude 200 meters at an angle of 150. So 150 will move from this side up to somewhere there. So this is our b2. So this is our b2, and then we've been told to say this is 150 degrees. Okay, so that is 150 degrees above the x-axis, and displacement b3. So b3, we don't know whether it's in the x, whether it's in the y, whether it's whether it's on the negative x, negative y, negative or positive y, positive x, we don't know. So we've been told to find b3. So in this case we cannot show b3 on the xy plane because we don't know its magnitude and its direction. So this is our x-axis, then this is our y-axis. So I'm going to show you how to solve this question, and I believe after you knowing this question, just you knowing how I'm going to solve this question, you'll be able to solve the other questions in a similar way, and you will not find any difficulties in this tutorial sheet. But even if you find any difficulties, I'm going to still solve the other questions. Don't worry, you still have the solutions. So let's quickly begin. So here we're saying, so this is what we've been given. So the first thing that I can advise you to do is first to draw the you draw the table of values. So this is the analysis table, the one that you're going to use to analyze your question. So let's start with B1. So B1, so here we have the x-axis, then here we have the y component. So in other words, you resolve all these magnitude, all these displacements that you've been given in two components. So you're going to resolve the displacements that you've been given in two components. So the first one that we have, we're going to resolve B1. So let me do this. Okay, so I'll write B1 here. So for B1, so B1 we've been told to say it's only in the negative x-axis, meaning it will only be this side. So if it's going in the negative, and we've been told to say the magnitude of B1 is simply just 100, so we'll write negative 100 because it's in the negative x-axis. If you want, you can say 100 cos 0 because the angle here is 0. Cos 0, of course, we all know to say it's 1. So cos 0, if cos 0 is 1 times negative 100, you still have negative 100. And then when we move on to the y-axis, do we have B1 moving in the y-axis? No, it's only in the x, so we write a 0 there. Okay, and then we move on to B2. So on B2 we also do the same. So B2 we have something like a triangle here. We have something like a triangle for B2. So this is our angle B2. And then we've been told to say this is the angle 150 degrees. So if this is 150 degrees, meaning this angle here is what? Is 30 degrees. So this B2, so if you want, you can use directly 150, but it is sometimes important and easier and more easy to use the angle here. Or maybe let's not confuse ourselves by using 30, let's just use 150 so that at least everyone can understand. So we're just going to use 150 to find the magnitude, the components of B2. So this is our B2. So the x component of B2 is simply just this one. So the x component of B2 is this one. So this one, according to SOHCAHTOA, if you have theta there, then you've been given the hypotenuse, which is B2, and then you're trying to find the adjacent to the angle. Given this angle, you simply say so you've been given the hypotenuse, and then you are finding the adjacent. So you're finding the adjacent, meaning you are going to use meaning SOHCAHTOA, from SOHCAHTOA. So from SOHCAHTOA you are going to use which is cos, because we have been given the adjacent and the hypotenuse, so we're going to use cos. So to find the component, the x component of B2, we're going to say B2 cos theta. So B2 cos theta is going to give us what? B2 cos theta, this will just be, B2 has been given to be 200 meters. So we say 200 cos, or what we can do is, let me just do this to simplify things. So in the x component, it's going to be like this, B2 cos theta. So B2 cos theta, we can just write it here, which is 200 cos the given angle, which is 150. And then here we want to find the opposite. This one is the opposite to this angle, so it's opposite to theta. So meaning to find the opposite given the hypotenuse, we are going to say we're going to use SOHCAHTOA, meaning we've been given the opposite and the hypotenuse. So we're going to use which is sine, since we've been given the opposite and the hypotenuse. So we're going to use sine. So we'll put 200 sine 150. 200 sine 150. And then now let's move on to B. Let's now move on to B3. B3. So have we been given anything about B3? We've not been given anything. So what we do is we'll just write our B3 there, and then instead of instead of writing anything, instead of writing numbers which have not been given, we'll just say the component for the x component for B3 is just B3 cos theta. We don't know our theta. And then in the y component we'll just write B3 sine theta. Okay, so now after finding all this, now to find the resultant component vectors, so to find the resultant component vectors both in the y and in the x, we add all these. So when you add 200 cos 150, so 200 cos 150, when you type this 200 cos 150 on your calculator, you get negative 173. So you are going to have negative 173. Negative 173, you add it plus that 100 there, so it will be negative 173 minus 100, which give you negative 273.21. So we are going to have negative 273 0.21, sorry, 0.21, negative 273.21. and then apart from that, you also add it to that. Okay, let me just do this. Let me just remove this last box. But if we were given the third vector here, would have added everything properly. But since my boxes are small, so I'll just write them down. So the resultant x component vector will just be equal to, or the resultant x component will just be equal to this. We said when you add the 2 there, you get negative 273.205. So this is what you are going to get. Then apart from that, you add it with that, so you say plus B3 cos, so plus B3 cos theta. And then this is our x component of the resultant. So we also go to what we've been given. So we are told to say this 100 was the resultant, and we've been given the angle for the resultant to be this. So the x component of the resultant vector is just 100. It's just 100 cos 37 degrees. So when you take this to the other side of the equal sign, just to make b3 cos theta as a subject, you make b3 cos theta as a subject, you're going to have 273 plus this, which will give you 353.07. you get 353.07. So what I've done here is what you exactly do with the second part here. So it's a 200 sine 150. We all know that sine 150, or if you punch on the calculator, it's just 0.5. When you multiply it with 200, you get 100. So when you add this 100, so we're now finding the resultant y component, which is equal to, so this one is saying 100, then plus b, 100 plus b sine theta. We are supposed to get this 100 sine the y component of the resultant vector, so it's going to be 100 sine 37. So we're going to have 100 sine 37, 100 sine 37 degrees. Then when you make b3 sine theta as subject, so when you make b3 sine theta as subject, you get something like b3 sine theta. When you make it as a subject, you get this will give you negative 39.818. Yeah, so now you have your equation 1, which is this one. So you have your equation 1, then this is your equation 2. So you can now solve these two equations simultaneously to find the value of b3 and cos theta. So how do you do that? So we can divide this. We know to say when you divide sine theta and cos theta, you get tan. So let me just erase this. We use this part for solving other things. Okay, so when I divide this sine theta, so I'm going to say b3 sine theta over b3 cos theta. So over b3 cos theta, this is just equal to, so b3 sine theta we know to say is equal to 353.07. So we write our 353.07. So if you don't want to divide the way I'm doing, you can just solve them the normal way you solve simultaneous equation, where you make at least one of those as a subject. You make either b3 or sine theta or cos theta as the subject, and then you find the required angles and everything. Yeah, so for me this is the simplest method. So you just divide these two, then you divide their corresponding values on the right. So this other side we have negative 39.818. So if you want, you can just say negative 39.82, still the same. So you can see that b3 and b3 will go. Sine theta over cos theta, you get tan. Sine theta over cos theta gives us tan theta. And then this is just equal to, when you divide these two angles, you get So that is 353.07 divided by that, you get negative 8. So you get something like negative 8.87. Negative 8.87. Then when you find now theta, so when you find theta, so theta will just be equal to the tan inverse. So the tan inverse of negative 8.87. So the tan inverse of this will just give us theta being equal to, so when you find the tan inverse of that, you get oh sorry, here I made a mistake. The one for sine is the one which has this small negative 39 and everything. Sorry for that error. Let me just erase this. Okay, so it's supposed to be negative 39.818 on top, and then here I'm supposed to get, here we have 350. Yeah, so we have 353.07. yeah, so when you divide that, you get negative let me just erase this. So you get negative 0.11 3. Then when you find the tan inverse of, so tan inverse of negative 0.113, you get this will give you negative. So let's do this. So negative 0.113. So tan inverse of this, you get negative 6.447. So this is what you are going to get. So this is what you are going to get. Theta will be negative 6.447. yeah, so apart from that, now here you can see to say the angle that we get, what that we've gotten is a negative angle. And as we all know, when you have a negative number, or whenever you have a negative angle, this implies that the angle is below the x-axis. So that negative 6 point something is below the x-axis, which is this one, negative 6.4 negative 6.47. so angles, normally you just round them off to one decimal place. So let's just write negative 0.4, negative 6.4. So now to find this other angle now which we are looking for, it means that we're going to subtract this negative 6.4 from 360, or rather, I mean, we're going to subtract this 6.4 from 360. So meaning when you subtract 360 minus 6.4, you get your theta now, which is the what is the angle, the needed angle, which is the displacement. Okay, sorry, which is the angle. So you're going to have your angle, which is your direction. So your direction of that will now just be equal to 3 353.6 degrees. So if you check, this is the answer which they also found here, such that I was rounding off a lot of figures. This is the reason why I found 6 here instead of 5. But in other words, this is approximately just the same answer. And then we can also find the other part now. So when finding the other answer, you can just simply use any of these equations. Yeah, so to find the magnitude or the displacement of that, sorry, to find the magnitude of this B3 we are looking for. So this is the angle for B3. I can just write this, and then we find the magnitude of B3. The magnitude of B3 will now be found by using any of these two equations. Like, so we're going to get this one. So to find B3, when you make B3 the subject of the formula there, it's just the same as 353.07 divided by, so you divide it by cos theta, and we already have our theta here. Our theta is just this angle here, so you replace your theta there to find B3. So you put your theta where there is theta here, so you say cos 353.6, so we're going to say 353.07, divide everything by cos 353.6 degrees. So you divide everything by cos 353.6 degrees, which is just going to give you B3 being equal to 355.1, which is just the same as 355 there. When you round it off, you get 355.1. Now since they want it as a whole number, so you just say 353 meters. Alright, so this is basically how you solve such questions. This is how you're going to solve the other remaining questions in the tutorial sheets, but I'm going to help you to solve all of them. I'll be solving one by one, sometimes 3 questions a day, sometimes 2. It's just that today I was very much occupied, and I almost didn't want to solve any questions, but I just decided to say, let me just solve for them at least question 1, and then we proceed just like that. So if you've not yet subscribed to the channel, click on the button just down below the screen which says subscribe, and then you will not be missing the videos that I'll be posting. So see you in the next tutorial video for physics or for math. Shalom, shalom.